Hello everybody, I hope you are fine. In this video I'm going to specify and estimate the same two-factor CFA model that I specified in the previous video, but this time I'm going to draw the model so that you can see how it can be done in EQS. Alright, this is our two-factor CFA model. The first factor is interpersonal conflict with 4 items, and the second factor is role conflict with 3 items. Okay, now let's jump to the software to draw the model. Alright, first let me open my data file. So this is my data file. I click on new model helper button, and this time rather than clicking on this button, I just click on diagram window. Okay, to add the variables, I just click on this button, which is V means variables, and then I click here. Now you can see a list of variables in my data set. I just scroll down and find my variables. I see 1, 2, I see 4, and also RC1 to RC3. So I select all of them, and then I click on this button, and then I click OK. Now you can see that all of my 7 variables are in the model. What I need to do is to click on this button, just rearrange the variables. And also these 3. Alright, now I have to add factors. So I click on F, I click here, and also I click here. So I have 2 factors here. Okay, now I'm going to connect the factors to the observed variables. So I just use this option here, and then I click on the factor, and then I click on the first observed variable, the factor, and the second observed variable, and you can see that it can be done very easily. Then I will do the same for the second factor. Alright, now these 2 factors should be correlated. I can either use this one or this option. It makes no difference. So I just select this one. I click on the first factor, then I click on the second factor. Now, as you can see, I don't have any scaling item here. So, as you already know, in CB-SEM, you have to fix one of the factor loadings to 1, or you can alternatively set the variance of the factor to 1. So it's up to you. In the previous example, we set the first factor loading to 1. Now I'm going to set the variance of the factors to 1 in this illustration. So I double click on this factor, and then I click on fixed parameter, and then by default the start value is 1, so I just click on OK. Now you can see that the color of the factor has changed, which means that the variance of this factor has been set to 1. So I will do the same for the second factor. Alright, now I'm done. There is no need for any scaling item in this model anymore, so I'm going to save this model. Model 1. Alright, now I click on title specifications. From the previous video, you already know that our data were multivariate non-normal, so I just click on robust methods so that we can have the robust statistics in our output. Alright, and alright, I just click on OK to see the EQX file. So the EQX file has already been generated. Here you can see the everything related to our specifications, the labels and the name of the variables in our dataset, the equations that can define our two-factor CFA model, the variances of the factors and the residual terms, also the covariance between our 2 factors, and you can also see that all of the fit indices are displayed in our output. So what I'm going to do is to save this EQX file. Alright, model 1. And now I'm going to run the model. Okay, so let me just go to our EDS file. To view the parameter estimates, I just select this option. And now you could see that the variances of these 2 factors are already fixed to 1. You can see the parameter estimates here as well, in case that you would like to see the standardized estimates, you can simply select the standardized estimates. Note that the correlation or the covariance between these two factors doesn't change, because these two factors have already been standardized, meaning that their variances are set to 1. So no matter whether you ask EQS to display the covariance or the correlation, the value is exactly the same because these two factors are standardized. Alright, now let's go to our output. Here we have the same situation, the same univariate statistics. You could see that we have multivariate non-normal data. We have the same cases with largest contribution to the normalized multivariate kurtosis, and as you can see, we really don't have any extreme multivariate outlier. We have the covariance matrix of our data. And again, this important statement, parameter estimates appear in order, no special problems were encountered during optimization. We have the residual covariance matrix as well as the standardized residual covariance, residual matrix, sorry. And here you could see the fit indices based on maximum likelihood, but you already know that these statistics are not accurate because our data are multivariate non-normal. But please bear in mind that since the degree to which our data are not multivariate normal, these fit indices are quite similar with the robust fit indices that are displayed under this section, under the robust section. So for example, if you compare the CFA values for the robust method, you could see that it is 0.956 and here it is 0.962. So it is because the degree to which our data are multivariate non-normal is not very considerable. Also here you can see that we have the model converged in 5 iterations. And remember, in the previous example, we fixed the first factor loading, the factor loading for IC1 to 1. And we didn't estimate this factor loading. But now, since in this example, we have fixed the variances to 1, so you can see that the factor loading of the first item of IC or interpersonal conflict factor has been estimated, and you can see the standardized value, you can see the second one, the third one, and the fourth one, and here you can see the standardized factor loadings. You can also see the robust standard error and Z statistics here. So these are the factor loadings that have been estimated. Here we have the variances. Again, you already know that we did not estimate any variances of the factors, so the variances of the factors have been set to 1, no estimation here. And regarding the error variances or the residual variances, you can see that we have the variances here and all of them are statistically significant. And you can also see the robust standard errors here. And we also had one covariance between the two factors, and as I mentioned earlier, the covariance and the correlation are exactly the same because the two factors, the variances of the two factors have been set to 1. And here you can see the standardized solution, all of the factor loadings and the R-square statistics for the items are displayed here. And finally, you can see the correlations between the two factors here. So it was all about the output for this two-factor CFA model based on robust maximum likelihood methodology. In the next example, I'm going to specify the same model and estimate it using PLS-E2 estimator, and I will also compare the results between PLS-E2 and maximum likelihood. Thank you very much for watching.